Assalamualaikum and very good evening. My name is Muhammad Arif Hakimi bin Muhammad YUSRI and my MATRIC number is 193473. I'm here today to talk to you about my final year project. My final year project is about the development of electric superchargers to improve engine performance. So first, internal combustion engine generate power through the combustion of either diesel or gasoline that has high number of carbons. The end product of this power generation process is carbon dioxide and nitrogenous gases. Uh, Nitrogen gas is very dangerous to environment since it can reduce the ozone layer and cause breathing problems to human being. Uh, Based on Internal Energy Agency, in Europe, carbon dioxide emitted by transportation is the second highest that contribute to global carbon dioxide, which is more than 20%. The improvement of car technology is growing and having an advancement since there are rules enforced to reduce the harmful gases from transportation, or can be said gas release from the engine. One of the exciting ideas to reduce the fuel consumption without any change to engine size or by reducing the engine size. So next, a lot of technology research and improvement has been done, and one of the promising solutions is the electrification of boosting system. Boosting system can be divided into two, which is turbocharger and supercharger. The two difference is turbocharger gain its power from exhaust and compressed air into the intake manifold, while supercharger is usually gain its power from crankshaft through the drive gear and compressed air into intake manifold. So I have three problem statement, which is internal combustion engine usually lost 30 to 37% of fuel energy through exhaust gas. Second is mechanical turbocharger does not allow high boost pressure at low speed, or we can say as turbo lag. And the third is mechanical supercharger consume energy from the engine since it required power from the crankshaft of the engine itself. So my objective is to study the characteristic of electric supercharger at different current, modify and fabricate the intake manifold with electric supercharger, and the third one is analyze the engine performance installed with electric supercharger. So the scope of the study is by using Subaru Robin EX70. The speed of engine used is from 2000 rpm to 4000 rpm. The experiment is conducted at ambient temperature. The material used for fitting is PLA, polylactic acid, and the maximum current and voltage supply to the electric supercharger is 12 ampere and 12 voltage. So here's the engine test bed used in this experiment, which is consists of dynamometer, pressure gauge, electric supercharger, DC power to power up the electric supercharger, and gasoline engine, which is Subaru Robin EX70. So here are the schematic diagram of engine setup. Next, we move to the equipment used in this experiment, which is Subaru Robin EX70. It can produce up to 5.7 horsepower at 4000 rpm, and the engine displacement is 169 cubic centimeter. Next, the electric supercharger. The maximum speed of electric supercharger is 5200 rpm, which is very noisy. The voltage supply can be maximum 17 voltage. Maximum current is 12 ampere. So here's the modification made, which is we will install the electric supercharger at the opening of the carburetor, and we mount the pressure gauge using the customized fitting to identify the intake manifold pressure and the gasoline engine itself. Next, here's the experimental procedure. which is firstly we will identify the characteristic of electric supercharger. We will control the current supply first, and then we will control the engine speed. Next, here's are the result of characterization of electric supercharger. The minimum pressure boost increase can be seen starting on the current supply of 3 ampere with engine speed of 4000 rpm. The highest pressure boost recorded is when engine is running at 4000 rpm with current supply of 8 ampere. The pressure boost increase as the current supply increase. At low engine speed and low current supply, the increase of pressure is not significant. The minimum pressure boost is achieved when engine is running at 2500 with current supply 8 ampere. So here's the summary of both combined tests, which consists of control current and control engine speed. And at high engine speed and high current, it can produce the maximum pressure boost. The engine performance by using 0.2 bar pressure boost is not significant, as the power increase by using electric supercharger is very small, which is 0.08, less than 1% increase of the actual engine power, and the torque increase by using electric supercharger with 0.2 bar pressure boost is only 12.14 Newton meter at engine speed of 2000 rpm. The increase is not very significant, and by using 0.4 bar, the power of engine increased by 4.45 kilowatt at 4000 rpm engine speed. The maximum power produced increased about 17%. The increase for every engine speed is about 2% to 10%. The increase of power is very significant, and we can say that the power is improved by using electric supercharger. Next, we move to the torque produced by the engine. The maximum torque is achieved by the engine is 12.31 Newton meter at engine speed of 2600 rpm. The maximum increase of torque is 13% when engine is running about 3200. And we can conclude that the torque of engine is increased and the engine performance is very significant. So I think that's all from me. Thank you.